Hello guys, welcome back to the channel again. Today we will solve the 23rd question of June Lead Code Challenge. So the question is count complete tree nodes. So we have given a complete binary tree and we have to count its nodes. Now first of all we must understand that what is a complete binary tree. So for understanding complete binary tree we will use this for example. So first of all the first diagram, which is this one, is a complete binary tree. Now why it is complete binary tree? Because each node have two nodes. So one have 2 and 3, 2 have 4 and 5, 3 have 6 and 7. So this is a complete binary tree. After that we come to this one, this second one. Here one have two nodes, 2 and 3, 2 has 4 and 5, 3 has 6. But the levels, here we have only, till here we have one level, here we have 2 level, and here we have 3 level. So we have every level of the node. Means if suppose it is of one node, then we have the level of second node also. So in this case this is also complete binary tree because each element or each node have one or two subnodes till the third level or till the final level. In this case also, here we have 0th level or first level. Here it is complete. Till here it has two nodes, so it is also complete. Now here we have both have one nodes. So here till here we have complete binary tree in this example also. Now if we take this example, one has two nodes, two has one node. So if we traverse till here, then we are correct. Now we will traverse this 4, but 4 does not have any node. It has 0 nodes and it is on the level second only. So we must have one element of 4 which should be on level third, or which will be on the bottom level. So in this case there is no such node, so we will not consider this to be a complete binary tree. So in the question what we will get, we will get a complete binary tree like these three. So what we have to do in the question, we have to count the number of nodes. In this there are 7 nodes, in this there are 6 nodes, in this there are 5 nodes. So the each number represents a node. Now we will directly see my solution, that what I have done in the solution and how we will traverse. So before looking at the solution, we will look at this definition of binary tree, that how binary tree is formed in this example. So the binary tree has name tree node. It is of type struct. We can also make using class, but it is a bit complicated. That's why we will not use class, we will use structure only, or lead code is previously using structure. Now after that I have the lead code I have created a val variable in which the value will be stored. Now it have two nodes, left and right, which represents the address of left part and the right represents the address of right part. If this is the number, then these two parts represents left and right. Now after this, if we have initialized the tree node with nothing, then this will be initialized with 0 and these both will be initialized with null. Now if we have initialized with some pointer, suppose if we have initialized with some x, now this x will be initialized by this both will be initialized by null. So this is similarly working as the constructor in a class. So these all three functions are the three type of constructor. In this, first is a default constructor, second is the constraint constructor, and third we have given three constructors, or sorry, three values. So this is the constructor overloading, you can easily recognize. Now in this third example we are giving all the three things. We are giving this value also, this address also, and this address also. So with the help of constructor overloading, we have done all these three using constructor and struct, or in structure only. Now how we will do the solution? This is the part which lead code already had done for us. Now what we have to do, we have to traverse each node of this tree which lead code have made for us. Now how we will do this? So first of all, I have initialized the count which will store the number of visited nodes. Now after that, I have called this function which will count the number of nodes, and at the end I will return this count which represent the number of nodes. Now what I will do here, first of all, I have taken root as an input which will store the current element in which we are. Now we will check that if current element is null or not. This is checked by this, or null pointer or not. So in this case, if it is a null pointer, then we will return and count will be printed. So initially count will be 0, so the root will be 0. Now suppose once this condition become false, count will be initialized. Now we'll check if the tree has left node or not. If tree has left node, then we will call this same function as left, and if it is have right node, now we have called this by right. So we are using recursion in this function. Now sometimes it is bit difficult to recognize recursion, so I am going to explain you this block of code properly with the help of tree. Now suppose we will consider this as a tree, so we'll understand this code with the help of this example. So we have tree 1 2 3 4 5 6 7, so we should return 7 as an answer. Now first of all, what I have done, I have initialized count, so count will be initialized with 0. Second thing, I have initialized this call with the root, and at the end I have written count. So we just have to look at this main code, that what this code is doing. So initially we will store this root as this 1. So initially what root is 1, so 1 is not null, so it will not return. So count will be incremented to 1. So now count we have 1. After that, what it will call? It will call left. So first of all, this is called. Now this left 2 will act as a root. Now we have a new tree. Which new tree? 2 4 5. So 2 represents the node or the root node. Now again this condition will be checked that root is null or not. So in this case also it is not null. Now what will be called? Left will be called. Now what all will be there in a stack? Till now what are there in a stack? Now in a recursion, if you know something about recursion, then you must know about stack. If you don't know, I'll tell you about stack. Suppose in recursion left is called. Now all the other statements will be stored in stack. So till now what is stored? Once right means once right is stored in the stack. Now again this loop is called. Now left is called. So what is there in the stack? There is right in the stack. So 2's right is also there in a stack. Now the condition is checked. Now 4 is not true. Sorry, the 4 is not null. So again count will be initialized. So count will be 3. Now after that this left will be called. So roots left and roots right. So roots right will be there in the stack. So 4 right will be there in stack, and this left will be called. Now left will be checked. So using this we have initialized with null pointer only. So this value must be null. So it will return. Now after returning, this condition will be popped, and we will use this value, or we will use this right. So now after that, what will be the value of root? Root will be considered as force right. Now force right is again also null, so we will return. Now this is popped. So what will be our stack? So a stack will look like this. Now what will happen? This will be popped. Now 2's right is 5. So before doing any other thing, this will be popped. So this value is popped. Till now, what is the value of this count? Count will be 3. Now we have called this 5. So 5 is checked that 5 is null or not. So in this case it is not null. So count will be incremented. Count will be equals to 4. Now again left and right two nodes will be called and both are null. Left will first be called and the second will be stored in the stack, and after left becomes null, this will call and this stack will become empty and only one element will be there in stack. Now what all we have completed till now? We have only one value in the stack, which is one's right. So till now what we have traversed? We have traversed this value, this value, this value and this value, and we have count equals to 4. Now what we will do? We will do the same thing for right also. Now we have one right in a stack, so this will be popped now. So one side is popped. Now after that this 3 comes because one side is 3. So this will be initialized with, or this will be incremented to 5 because 3 is not null. After that its left is called and right will be stored in the stack. After that this left 6 is traversed, this will be incremented by 6. Now left will be called, right will be stored in the stack. After that same thing will occur, and at the end count will come on this, or the root will come on this. This will be incremented to 7. After that left and right will be again called, then both will be null. So this stack will completely become empty. So after the stack become completely empty, this function will be terminated and count will store the value 7. So this 7 will be returned. Here we have returned this 7. So this is the simple recursion function in which two recursion functions or two calling of the function is used, and the breaking condition or the terminating condition is that if the value of the root becomes null. So in this case the answer will be 7. I have explained you all about the stack, all about the recursion in this video. So if you want to learn more things about recursion, binary tree or many things about competitive programming, you can subscribe my channel. Thank you guys. For more such content, like, share, comment and don't forget to subscribe.